Okay, for number 14, we're going to do another trig integral here. We have the integral from 0 to pi of sine to the fourth of x dx. So we have an even power of sine, we have no cosines. So we can't use any sort of u substitution. We're going to have to use power reduction formulas. So remember that you have a formula that says sine squared of x is equal to 1 minus cosine 2x over 2. So since we have sine to the fourth, we have that squared. So we can substitute using that first. So we have 1 minus cosine 2x over 2 quantity squared dx. That's going to help us a little bit. We can put this 1/4 out front from squaring the denominator. If we square the numerator, we have to FOIL that out, expand it. So we'd get 1 minus 2 cosine 2x plus cosine squared of 2x. So the first two are very easily done by standard methods. For this third part, we're going to have to use another power reduction formula. So we also have the formula that cosine squared of, let me write these formulas as theta because we don't necessarily just have x. I'm writing those formulas as theta because we don't necessarily just have x in these. So cosine squared of theta is equal to 1 plus cosine 2 theta over 2. So we have 2x, so that's going to end up giving us a 4x. So finally, our integral becomes 1/4 from 0 to pi. We have 1 minus 2 cosine 2x, and this one here is going to be plus 1 plus cosine of 4x over 2. So now everything is at single powers of trig functions, and this can be done a little bit simpler. One last thing I'm going to do is combine like terms before we take the antiderivative. So if you divided both of those terms by the 2, we'd have 1/2. So 1 plus 1/2 gives us 3/2. We get minus 2 cosine 2x, and then we get plus cosine of 4x over 2. So now we're ready to take the antiderivative. So the antiderivative, we're going to leave this 1/4 here. The antiderivative of 3/2 is just going to be 3/2 x. When we take the antiderivative of cosine, we're going to get sine, but because there's a 2 in here, we'd have to divide by 2. We already have a 2, so this is just going to be sine 2x. Again, these are really easy to check by just redoing the derivatives in your head. Derivative of sine 2x is 2 cosine 2x. That's exactly what we have. And here, on the same token, we have a 4 inside, so we're going to have to divide by that 4 when we change this to sine. So we're going to get sine 4x over 8. And this is all going from 0 to pi. Well, one thing that you want to recognize then is that since these signs are with integer multiples of x, if we plug in 0, it's going to be 0, but if we plug in pi, they're also going to be 0 because we have sine of an integer multiple of pi. So these two terms right here are 0 both times no matter what. And the only one we have left then, 3/2 x, that's 0 when we plug in 0, so we don't even have to subtract anything. We can just plug in the pi right away. So what do we get? We get 3 over 8 pi as our final result of this definite integral. And that is on your answer key as letter C.